This campus is the National Environment Centre. These buildings sit almost in the middle of a 400-acre certified organic farm that has been designed using design tools to help us try and develop food production systems in uncertainty. The aim of this little presentation is to discuss some of those design tools and talk about how you could apply them in designing for uncertainty in food production systems. We're looking here at the 7 Mile Creek, which runs through the middle of our organic farm. This picture was taken some time ago. It hasn't looked like this for a while. One of the uncertainties that we have on our farm just north of Albury is the uncertainty on how much rain we get every year and when it's going to fall. We also have an uncertainty about how reliable it will be in the future. This picture here is fairly typical of our farm landscape. We have drainage lines that run up across pastured slopes, which is the main production areas of our farm, to treed hilltops. The drainage line areas are either wetlands or treed or something like that. The hilltops are all treed as well, and both those areas help to modify the climate, the water, the way the air flows, and the way the water moves through the productive areas of the farm. One of our design tools we call slow the water down. Originally this landscape was woodland, and rain events would have slowly drained out of the landscape over time. Agriculture has modified it so that it's really a grassland, and so as the rain falls it runs off very quickly. Our creeks get really high and flood very quickly and rapidly, and then the water's all gone. Whereas previously those creeks would have run for a much longer time. One of our strategies for slowing the water down is these things called leaky dams. Looking at this picture here, you can see a green bank in front of us. It's only quite small, less than 1 metre high. Now, normally when you make a dam wall, you key the base into the clay underneath so that there's no way for the water to drain through. Those dams are for storage of water. These dams, or these banks, are just really to slow the water down. So what happens after a rain event, the water runs down our drainage lines and pools behind these leaky dams, and over a number of days the water is slowly released underneath the dam wall and moves down further down the drainage line. This has a number of effects. Firstly, it modifies the climate and the habitat in the paddocks next door. It creates habitat, ephemeral wetlands and habitat in the drainage lines themselves. But also at the bottom of this drainage line we're looking at here, after a number of these leaky dams, is a storage dam which we pump water out of up onto a hill for all our livestock. So these leaky dams also act as a water cleaning mechanism to make sure we have quality, fresh, clean water for our livestock. Another one of our slow the water down techniques is to use pattern ploughing from keyline. You can see in this picture here the paddock's been pattern ploughed only recently, and you can see how the water would not only slowly move and infiltrate into the soil as it moves down the slope, but also spread out across the slope. Another one of our design tools is about minimising the amount of industrial energy that goes into our farming system. You can see this outcrop here. We term that a permanent outcrop. It may last for anything from 2, 3 up to 7 or 8 years. The idea is that we sow it once, we use it for grazing through the winter, we let it flower and set seed. The seed drops to the ground over the summer. We use the seed on the ground as feed for our lambs in the autumn until the amount of seed left on the ground is the right density. We lock it up and then it starts all over again. It has the effect of producing an outcrop without any energy input at all after the first year. Another of our design tools we call Cog Systems versus Bug Systems. It's really about trying to design complexity into your farm systems and into your farm landscape. A Cog system is where you've got known inputs and you put the parts of the system together like cogs. You know exactly how they're going to behave, and in the end when they all work together you get a known output. Cog systems work well when you do know exactly what the inputs are. Designing in uncertainty, we don't know what the inputs are. We don't know what our rainfall is going to be, what its pattern is. All sorts of things are uncertain. We use a bug system. Now the analogy we use there is if you threw a crumb of bread onto the ground near an ant's nest, 7 or 8 ants would wander over and pick up that crumb of bread and start carrying it back to the ant's nest. One would be pulling it north, one might be pulling it east, one might even be sitting on top of it, but 4 or 5 would be pulling it roughly in the direction of the ant's nest. In the long run, it would get there. If we took 1 or 2 of those ants away, the crumb would still get there. We don't know, in that situation, we don't know exactly what the inputs are, but we still get to where we want to go. A bug system. It's really about designing multiple pathways, multiple complexities in all the stuff in our farm system. This picture in front of us here is a very simple example of that. They're our Damero ewes with their lambs. We have predator problems, foxes, dogs at the National Environment Centre. Occasionally alpacas don't stand up to a determined pack of dogs, but a donkey does. The complexity of our predator control makes sure that it happens, doesn't matter what the inputs are. Going back to the uncertainty of water in our farm system for the moment, one of the design tools we use there is to focus on maximising the amount of soil carbon we have. As a rough rule of thumb, we reckon that for every extra percentage of carbon you have in the soil, it's another inch of rainfall you can store. This is soil out of paddock 3 on our farm, and it's got 3.7% organic carbon in it. Okay, it can store a lot more water than paddocks with less. Another one of our design tools is to try and select parts of the farm system that do well under a broad variety of conditions. It's very easy to think that the best way to go is to select the plant or the animal or whatever that performs particularly well at the best conditions, but those may not perform particularly well under less than ideal conditions. The approach we take is that it's better to get a harvest or a crop or an output through most years rather than getting a really good crop or an output now and then. This picture here is of our Damero sheep, who do particularly well across a broad range of conditions, and we're particularly pleased with the way they fit into our farm system at the NEC. Another of our design tools is marketing. The picture we're looking here is one of our little stands at the farmers market. We consider that when you're designing in uncertainty, it's very difficult, if you don't know what the inputs are, to know exactly what the outputs are. The idea that we should be able to produce lambs, in this case, of identical weight and identical fat depth to suit a particular set of framework year after year, season after season, no matter what the season throws at us, is a bit unrealistic and probably not environmentally sound as well. Our marketing works so that our customers, which we talk to every week when we sell, understand that our system works so that they are buying lamb that comes off the farm no matter what the conditions are. Most of our customers see that as a positive rather than a negative.